I'll call this the innermost layer. This one will be the middle layer. And these two are the outside layers, outer layers. So you might be a bit, you might struggle a bit to visualize, but how I would like to describe it to you is you just imagine a building, right? This is like a 3-story building because this is the first floor. The first floor is over here, first floor. This is the second floor. This will be the third floor. So in order for these 2 blocks to be on the third floor, these 2 over here, sorry about that. In order for these 2 to be on the third floor, there needs to be a base for it. So below the third floor, there would have been the second floor built as well as the first floor built. So I think this will help you to better visualize that. So what is unseen, what is being covered over here? There's one more block here that is unseen. So if we go just by the innermost level, 1, 2, and then 3. The innermost layer would look like this. This is what the innermost layer will look like. And this will be what is being obscured from you by those in front. So I'll just erase this to make it a little easier to see. Yeah. So this is the inner layer. Can you imagine this? Okay. So in the inner layer, how many are there? 1, 2, 3, 4, 5, 6, 7. So the inner layer has 7 cubes. Next, we take a look at the middle layer. Same concept. If there is a second floor over here, there must be a first floor at the bottom to support the second floor. So the middle layer has 1, 2, and then 3. 3 cubes. Right, so this middle layer would look like this. And the one that's shaded is the one that's being obscured. And the outer 2, I just give it away. The outer layer, obviously, as you can see, are unobscured. So there's 1 and 2. So 2 cubes. How many cubes are in the solid? You can just write it out. 7 plus 3 plus 2. 12. So 12 cubes. I'll write it in a more in the way you should present your answer. So number of cubes in solid, 7 plus 3 plus 2, so 12. Volume of each cube. The question has already told you that the cubes are 1 cm cubes. And if there's anything that you should know about cubes, is that the length, the breadth, and the height are all equal. Because all sides, all faces of the cube are made of the same square. And square, all 4 sides are equal mass. So same concept for this. Length, breadth, and height will all be equal, 1 cm. Volume of 1 cube is length times breadth times height. Or I think length times base times height. Length times base times height. B will represent base. 1 cm times 1 cm times 1 cm. we give you 1 cm cube. Then because there are 12 cubes, which all have the same length, base, and height, verify the B stands for base. The volume of the solid will be 12 times 1 cm cube to give you 12 cm cube. So here it's 12. Sorry, this is a bit messy. Let me clean it up. So if you understand this, then I will move on to the next question. Question 20. Jerry bought 3 meters of ribbon. He gave 29 meters of ribbon to his friend. What was the length of the ribbon he had left? So there's a key learning point here, something that a lot of people might misread. Here, the question states 29 meters of ribbon, not 29 of ribbon. The difference here is that if it's referring to 29 of ribbon, then let's say just this ribbon, let's split it into 9 equal parts. 29 of ribbon, which would mean that 29 of it is being given away. And Jerry has 3 meters. So this would mean that 29 of these 3 meters is being given to his friend. However, that is not what the question is asking for. Not what the question is asking for. Instead, what the question is asking for is 29 meters of ribbon. So this means, okay, let's use the same model. Okay, never mind. I'll just draw another one to help you visualize better. 29 meters of ribbon means that because this meters is a measurement, it's a unit of measurement. So 29 meters means that the ribbon that he gives away is 2/9 of a meter. This means that this is 1 meter. The amount that he gives away is 2/9 of it, 2/9 meters. So that is the difference. If there's a measurement here, then you cannot assume, if there's a unit of measurement here, like meters, you cannot immediately assume that the ribbon that he gives away is a proportion of what he has. It has to do with the unit of measurement here. So what was the length of ribbon he had left? We'll just simply take 3 meters minus 2/9 meters to give you 2/7/9 meters. Let me check whether the question wants you to present it as an improper fraction or mixed number. Yeah. answer key is not reflective of the correct answer. The correct answer is what I wrote there lah. Okay, so let's move on to question 21. George had 29 kg of flour. He used 1/3 of it to bake a cake. How much flour did he have left? So this is the same concept as the previous question, except it's the exact opposite lah. 1/3 kg of flour versus 1/3 of flour George originally had. So in this case, this iteration of this question type, instead of 1/3 kg with the units, there's no units over here. So it's literally 1/3 of the 29 kg of flour. So if you use 1/3 of it, then 1 minus 1/3, oh, sorry. 1 minus 1/3 means that he has 2/3 of it left. So since he has 2/3 of it left, you can just take 2/3 times 29 kg, 2/9 kg. This will give us 4/27 kg. Next, we have question 22. A bag contains some red, blue, and green beads. The ratio of the number of red beads to that of blue beads is 2:3. The ratio of the number of blue beads to that of green beads is 9:7. What is the ratio of the number of red beads to that of green beads? So first we'll look at what is the medium of comparison here. The first statement, red beads and blue beads. Second statement, blue beads to green beads. So blue beads appears in both statements. However, blue beads takes on the proportion of 3 here and the proportion of 9 here. Take note, proportion does not denote the exact values. So this doesn't mean that there are 3 blue beads, and this doesn't mean there are 9 blue beads, but y'all probably already know that. So let's just write out first. Red is to blue would be 2 to 3, and then blue is to green is 9:7. So the good thing about this is that 3 can easily be converted to 9. Likewise with 9:3. But I think it will be easier if we just convert 3 to 9. Okay, so I'll just write it out here first. I will take you through my explanation as we go. So we'll just leave the green blank here first. So 3 here, then 9 over here, and then 7 over here, right? Because the number of blue beads remains unchanged in both statements, the number is still the same. It's just the proportion used to describe it is different. So we can also increase the proportion of we can increase the number used to denote red over here. This one you times 3. This one you can also times 3. So the key thing to take note here is if you times, for any ratio, if you times one of the sides by a certain value, you have to times the other side by the same value to keep the same proportion. So 2 times 3 will give you 6. See, if you write it out as a fraction, right? 2/3 also equals to 6/9. So this is how you know that the proportion is still equal. What is the ratio of the number of red beads to that of green beads? Red to green. See, now that you have the same medium of comparison, it's a lot easier to tackle the question. since this is the same, you can just write out the ratio without the blue. So your final answer will be, because they asked red to green, so you have to write it in the same order, 6:7. Question 23. Sam had $96 more than Henry. After spending the same amount of money, Sam had twice as much money as Henry. How much did Henry have left? So for this kind of question, where they give you thrice as much, twice as much, this kind of descriptors, I would like to use a diagram to visualize it better. So let's say over here, this over here is $96, right? Sam had 96 more than Henry. After spending the same amount of money, Sam had twice as much money as Henry. Twice as much means that how much? How much more did he have than Henry? 2 units more, right? All this is spent because they spend the same amount. So this is the same amount. Sam had twice as much as Henry. See, does this diagram check out? Right? 1, 2, 3 units, and it's only 1 unit. How much did Henry have left? So using this diagram, you can see that these 2 units over here are $96. So 2 units, $96. 1 unit would be 96 divided by 2 gives you 48. How much did Henry have left? Henry has 1 unit left. So effectively, Henry has $48 left. That's your answer. Question 24. At a party, 5 children shared 7 pizzas equally among themselves. What fraction of a pizza did each child get? So we'll tackle this question logically lah. Like using the interpretation of the question. 5 children shared 7 pizzas. So what would your first thought be? 7 pizzas divided by 5 children. 7 pizzas divided by 5 children, 7/5. Let's work. So, what fraction of a pizza did each child get? Usually people will just, they won't think so much and then they'll just stop over here. But this is not the correct answer because they're asking you not what fraction of the pizzas did the children get, but what fraction of a pizza. If they ask you what fraction of the 7 pizzas did each child get, then perhaps 7/5 would be a correct answer, but they're asking for a fraction of a pizza. So how many pizzas are there? 7, right? So you can just take this 7/5 divided by 7 to give you 1/5. So each child got 1/5 of a pizza. Okay, we'll draw this out to help you better visualize it. So, 1 pizza, 2 pizza, 3 pizza, 4 pizza, 5 pizza, 5 pizza, 6 pizza, and 7 pizzas. Okay, let's say because the final answer here is 1/5, right? Let's divide each pizza into 5 parts. Okay, I'm struggling to divide it, but you get the idea. 1/5. 1, 2, 3, 4, 5. So say there are 5 children. If each child gets 1/5, so this is child A, right? The first child gets 1/5 of a pizza, 1/5 of the second pizza, 1/5 of the third pizza, and then so on and so forth. This would be their share, correct? Then the second kid, let's give him green. And then for the next child, and then you can also visualize for the other two. Like I won't spend so much time coloring. So yeah, you can help to double check your answer. Each child gets 1/5 of the pizza. Next question, question 25. The following solid is made up of 9 cubes. Shade the correct number of squares to complete each view. So from the top view, this one also, okay. So you need a bit of visualization skills. 1, 2, 3, 4, right? 1, 2, 3, 4. Then here from the top, you will see 1, 2, and 3. Because from the top, you won't be able to see this little gap gaping inside. But because there's still a block here, you will be able to see something over here. Hence, you will shade this one that's in the middle. And you will also shade the more obvious one that's on the top here. 1, 2, 3. Then next for the side view. The side view, you will be able to see 1, 2, and 3. This one you don't need to include. Why? Because this one is already being covered by this. It's being covered by the box in front of it. So 1, 2, 3 is correct what you see here. 1, 2, 3. But it doesn't take into account the second, I'll go back to my previous analogy of floors, the second floor. 1 over here, and then 1 over here. But in the middle, there's nothing, right? In between these two. In between these two, there seems to be nothing. So we'll just leave a gap over there. 1 and 2. Okay, I'll just erase this to make it look neater. But yeah, you can visualize. There's nothing in the middle here. So you don't need to shade anything here. Next, question 26. In the figure below, ADC is a triangle, BDC is an isosceles triangle. Find angle DCB. So first, what are the angles you can find from the information given? Then next, what angle properties can be used to find the required angles? What angles can you find from the information given? Information given, they only gave you 85 degrees as well as 65 degrees. Using the property of angle sum of triangle, you can find angle ABD, right? And from ABD, you can find this angle over here, which is DBC, because of the angle property, angles on a straight line. Then subsequently from here, you can find